Hey guys, this is Mitch with Fine.CGI, and today we're going to talk about how to integrate Entity Core Framework into Godot. So we're going to go through the process of discussing what Entity Core Framework is. We're going to go through and talk about how to use it, how to create your model objects, how to insert data. Then we're going to talk about how to select data. We're going to talk about how to update data, delete it. We're going to talk about how to create custom commands. And finally, we're going to talk about some of the limitations within Entity Core Framework and a way to kind of work around that limitation. So that's what I have in store for you guys today. So let's go ahead and get started. Okay, so the first thing we have to talk about is what is Entity Framework Core. An Entity Framework Core is a free open source library provided by Microsoft that allows you to interact with a database without using SQL. So Entity Framework Core is what's called an ORM, or an Object Relational Mapper. Now, the simplest terms of what an ORM is it maps objects to databases. So basically you create a model object, so something like a player, right? And it maps it automatically to the database for you, so you don't actually have to go through and do any of the SQL or any of that stuff. So how does it work? Well, Entity Core Framework uses what's called a DB context. And a DB context is like a central class in Entity Framework that basically acts as a session with the database. So think of it kind of like a person. You say, hey, I want to get information, or I want to save information, and that person takes that command and interacts with the database for you so that you don't have to directly go to the database and interact with it. The DB context basically tracks the changes that are made to your entities, and entities are just objects. Basically, think of it like a list of objects, and it applies those changes to the database when the save change is called. So basically, when you hit save change, you're loading all that data into the database. So you want to be cautious because that's when all of the interaction is going to happen. And that can really affect your performance if you do it too much or too little. So you kind of want to find that nice balance there. Now, since Entity Framework actually keeps track of all of your changes, this allows you to update the database extremely efficiently. Because if you interact with the database, let's say you want to insert a player and they have guns, right? Typically, you would insert the guns and then you would insert the player, and those would be two separate calls unless you do a transaction, right? With Entity Framework, you can make adjustments to all of your guns and make adjustments to your player and say this player now has these guns without actually touching the database. And then once you're happy, you just say save, and then it automatically does it all in the most optimal way, which is really, really nice. So you can see here, this is kind of how it operates, is you have a class called player, you have a context called player context, and then you have a data table that houses that player's information. So that's really cool, but how do you actually query data? How do you save data? Well, link is how you actually interact with your database. So you can see here, this is one of the big advantages to Entity Framework. If you look at this, you can see what we do here is we basically say, I want to select data. So I'm going to use my context, which is my player context, and I'm going to say, I want to select my players. So context.player. So I'm pulling back my player data where my name is equal to find.CGI. And then I want to drop that into a list. And that's it. That's all I have to do. I pull back my data, no problem. Versus if we were doing something more like a SQLite connection, you can see here, this is how we would do a SQLite connection. So we would pull back our connection, we would use that connection, we'd open that connection, run our command, which is select star from players where name is equal to our parameter 1, which would be find.CGI in this case. Then we use that command, we execute that query, we add our stuff with a value, and then we execute that non-query. Now, of course, this doesn't include the returning that data. Technically speaking, you would also do a command dot result, I believe it is, and then you'd pull back that data, assign it, and then return that data, and then close your connection. And that's kind of how this would be approached. But you can see, even with just this little bit of information, it's way simpler to interact with your database. So that's really cool, but what databases are supported? Well, there are major databases that are supported, and then there are kind of minor databases that are supported. The major ones include SQL Server, SQLite, MySQL, Postgres, Azure Cosmos, and then your in-memory provider, which is basically like an in-memory database. Other databases include, Oracle, SQL Server Compact, Firebird, IBM, SAP, Jet, and Maria. Now, the reason why there's major and minor is that, one, the major ones are all contributed by Microsoft and maintained by Microsoft. The other ones are community added. So, your mileage may vary on how good or bad they are. And also, you'll notice that since there's multiple databases supported, your question might be, so what happens if I'm on SQLite and then suddenly I say I want to use SQL Server? Well, thankfully, it's really simple. You basically just switch your provider, switch your library, and you're done. And everything else just works. So the beauty of it is that you can kind of change databases relatively simple. So you can start with a small project and say, I want to use SQLite, and then migrate to a bigger database. Now, that being said, you're not going to be able to migrate the data over super easily. You'd have to do that in some other way. But migrating all of the connections and all of that stuff is really simple with Entity Framework. So that's basically what Entity Framework is. Now let's talk about how to use it within Godot. All right, so the first thing we need to do is install Entity Core Framework. The easiest way to do that is to do it via Visual Studio Code. So we'll go ahead and do that. So we'll create a user interface scene here. We're going to right click, attach a script, and we'll say Entity Framework Tutorial, and we'll change the language to C#. Click Create. Now, if I maximize this up right here, you'll see that we have a script. Now, for us to be able to use Entity Framework, we actually need to install it. So to install it, all you have to do is click on these three little dots up here, Terminal, New Terminal. Now, if you're using Visual Studio, you can just go out to the Visual Studio Package Manager, so the NuGet Package Manager, and go ahead and just install it. But in my case, I need to actually install it manually. So we're going to need to go through a little bit more of a process to actually do it. So first things first, we're going to say .NET add package Microsoft, and I'm going to close this, .entity framework core dot, and then we get to choose our database provider, which in my case is going to be SQLite. So SQLite -- version, and in the case of the writing of this tutorial, we're going to pull down version 6.0.25. And the reason why is because each version of Entity Framework matches with a version of .NET Framework. So if you are using .NET 6, which in the case of this tutorial, because Godot hasn't quite upgraded up to 8 yet, we're going to install version 6.0.25. So we'll hit enter. We'll let that install. It's going to take a few seconds. And there we go. And then we're also going to pull down the exact same version of design. And design is really important because it's going to give us a lot of additional features within our project. So we'll go ahead and grab that. And you'll see once it says, hey, everything's downloaded, everything's installed, we're good to go. So the best way to see is if you look at your CS proj, you can see right here we have these package references here. And as long as we have these package references, we should be good to go. So that's just something to keep in mind. Now, if you want to use something like .NET 8 or something like that, you can just change your target framework right here to .NET 8 and then change this as well to .NET 8, and that should work. And then you'd have to change your Entity Framework version up to 8 as well. But in this case, I'll just stick with 6 because 6 is very stable and easy to use. So in order to use Entity Framework, we need to create what's called model objects. And model objects are basically just objects that house our data. So in our case, let's go ahead and create a very simple model object. First, I'm going to create a folder. I'm going to call it models. And I'm going to create a player.cs. Now, I have GitHub Copilot, so it's going to try to automatically do some stuff, so I'll ignore it. But if you see some pop-ups, that's because of that add-on. So we'll say public class player, like that. And you'll see it's going to auto-suggest some stuff. And really, I'm going to use all of these, but we'll type public int ID, and we'll use a get semicolon set semicolon like that. And then we need to pass in some kind of name. So public string name, and we'll use get semicolon set like so. And then we could also throw in additional information if we want. So stuff that a player might need. So in this case, GitHub Copilot is actually already coming in with score, so we could add that. If we wanted to add something else, like for instance, like their ELO level, right? Like that, we could do that as well. But basically, we just define what our object is going to be. And this is going to kind of correlate to our actual database itself. So that's kind of the cool part about this. And now for us to be able to interact with a database, we need to actually come up with what's called a context. And a context is how we actually hold on to our information and how we keep track of that information. Now, the nice thing about context is typically you only have one if you are trying to handle one database. If you want multiple databases, you can pull different contexts up. So think of it kind of like typically, right, in my experience, we have like an application context, which is basically our entire app. And then we have a logging context, right, where all of our logs are located in a separate database. So think of context as your actual database itself, more so than just a section of a database, if that makes sense. So I'm going to create a new file and I'm going to call it game context. And what I'll do is I'll say public class game context. We're going to inherit from DB context. And you'll see that it's going to automatically pop in using Microsoft Entity Framework Core. Now, this is going to do all sorts of random stuff because for whatever reason, GitHub Copilot is being really weird. So we'll ignore that. We'll say public DB set. We'll pass in players like that. And then we just have to create a constructor. So we'll say public game context, parentheses, brackets, and then we'll basically create our database. So database.ensure created. And that's going to ensure that our database is actually created. And then we'll go ahead and start configuring our database. So we'll say public protected override void, and we're going to override the on configuring method. So we'll pass that in. And we don't need to execute our base. We're good without doing that. So we'll do that. We'll say options builder dot use SQLite. And basically this tells Entity Framework that we're using SQLite. So if we wanted to use Microsoft SQL Server or something else, we could change this to Microsoft SQL Server or MySQL or Postgres or something like that. Now we can pass in where we want our stuff to be located. So we'll say data space source is equal to, and we'll put in sample data.db like that. And that's basically all we have to do for it to create our database. And now all we have to do is basically set it up so that this code runs. And it's actually really easy. All we have to do is come into our Entity Framework tutorial code here. And under ready, all we have to do is say using var context is equal to new game context, like that. Then we can hit bracket bracket. And then in theory, if we're lucky, it should just work. So we can just come in here, save our control node here, hit play, and Godot will execute. And you'll see nothing has changed. But if we right click, open in File Manager, you should see a database.db right here. So it automatically went and created a database. Now you might be asking, okay, cool. How do I actually view this database? Because right now it's a .db file. I really can't open those up. Well, that is where DB Browser for SQLite comes in. It is widely considered one of the biggest database tools for SQLite. Now, in our case, since we're using SQLite, we'll be using this. If you're using a different database, use your whatever comes with your database that you would like to use. In my case, I'll be using this. So we'll come up here, click on download, and then we'll download the Windows version. Now, in my case, I usually pull the zip version, no installer, just because it's a little bit easier to work with. So we'll download that. We'll click the file icon and then right click, extract it, extract. And then if we open this guy up and we find the executable, which I believe is right here, we'll double click on it. And you'll see here's DB browser for SQLite. Now, what's really cool about this is if we come into our project here and we drag our database.db into here, you will see that we have a players table already built for us. And the coolest part is you can see it has ID, which is our primary key. We have name, we have score, and we have elo, which is really cool. Now, what told C# that this was an actual table? Well, when we defined our actual game context here, we said a DB set is player. We said that it's a list of players. So now the question is, how do we actually insert data? And that's actually really easy. All we have to do is go into our entity framework tutorial. And instead of doing this using context is equal to new game context, let's come up here and say game context is equal to new game context. That way we just hold on to that data for basically ever. So that way we have that data just on demand. And then all we have to do is if we go into our Godot project here, we can come up here, right click, and add in a new child node. Let's add in a button. So what we'll do is we'll insert some data here. So it's going to be something relatively simple. So we'll say insert data. And what I'll do is I'll right click, add in another child node, and let's add in a text edit like that. Now this text edit is going to allow us to input some information. So that way we have some way of, inputting information so we can test our code. Now, if we look at our database, we have a name, score, and elo. Now, in my case, I'm just going to allow them to insert their name real quick. So I'll right click, add another child node. Let's add in a label and let's just type in name like that. And now all we have to do is click on our insert data. So we'll say insert data. We'll go into our node button down. I'm going to copy this guy, connect it, and I will say public insert data button down. Now, what this is going to do is it's going to allow us to insert some data. Now, of course, if you don't want to do that, right, if you want to insert data in some other way, you can basically just pull the button out and then just use the code inside of the button wherever you want to insert your data, as long as you have access to this game context. So, typically people like to put those in game managers, or people like to put them out somewhere where they're universally accessible, which is like a singleton, or in my case, I usually like to put them in game managers. Now, to insert our data, it's actually really easy. All we have to do is create an entity and then use that entity. So in my case, I'll just say var current players equal to a new player. Now I'm going to pass in some parameters here. We're going to type name is equal to $, get node bracket as a text edit dot text. And we'll pass in a path. And in our case, our path should just be text edit. So we'll pass that in. I'll put a semicolon at the end. And then if we want to save, all we have to do is say context.players.add. And then we'll go ahead and add our entry. So our current player. And then we'll say context.save changes. Now, let's take a step back and talk about this. So this is me creating my player, right? This is me adding my player to my context. It's saying, hey, I want you to track this information. A lot of times when you do this, you don't know, you may not want to create a new player and then add it to the context. A lot of times you might want to pull that player information and keep it, if that makes sense, and then update that information or add it as needed, if that makes sense. But in this case, since it's a relatively simple tutorial, we'll do it this way. Now, when we do this, we can just hit play and you'll see it pops up and we could type test, insert data. Now we got an error. Microsoft Entity Core Framework, and it's gigantic, right? If we type in test and we hit insert data, in theory, if we click on our DB browser for SQLite, and we click browse data, you will see that it has now inserted test score of 0, elo of 0. If we click insert data again and we refresh our database, you'll see that we have test ID of 2, test score 0, elo 0. So if I type find point CGI, I click insert, I hit refresh, you'll see there I am. So it's really that easy to insert data. And thankfully, it just basically gets handled for us. So that's awesome. So what happens if we want to select data? So to select stuff, what we have to do is we have to come into here. We're going to take our insert data. We're going to duplicate that, drag it down, and let's change this to select data. Now I'm going to right click on this, disconnect it, right click, connect. I will Control A, Control C, connect it. We're going to come down here and say public void paste like so. And then if we come back here, we can change this to select data. So if I select this guy, select data, you'll see that it is hooked up just right. So there we go. Now, when we want to select data, it's actually relatively easy because the whole purpose of this is to make it really easy. So all you have to do is just grab your context, which is right here, and basically just say var players is equal to context.players dot, and this is where link comes in. So this is how you do your actual selection statement. So context.players is actually all of the data inside of this table. So what I can do is I can say dot players dot where e equals pointer e dot name is equal to, and I'm going to pass in find point CGI. And what this is going to do is it's going to make our stuff really easy to manage. So that's basically really all we have to do for our actual selection statement. And what this will return is it's going to return an iQueryable player. So what we need to do is we need to .toList this like that. And that's basically just telling it that we're going to get back a list of objects. And then we could just say gd.print players bracket bracket 0 because we only have one .name comma, and I'm going to go ahead and print out the rest of this information. So I believe it's player.elo and player.score, if I remember correctly. So we'll do that. We'll put a semicolon right there, and that's literally all we have to do. And if we take a look at this, you can see it's a lowercase f, so it would have came back with nothing. So let's go with a lowercase f so I don't crash out my system, because technically, if we wanted to be very safe about this, we should say if players.count is greater than 0, then go ahead and do this bit of information here. That way we don't crash out our game, because if we do that, it will crash out our game. So we'll do that. And then if we come back to our Godot project, we refresh it like so, you'll see that when we click on select data, it should come back with find point CGI 0, 0. So that pulled back my actual find point CGI information 0, 0. Now the cool part is, let's say I come in here and I set this to 100 and I set their elo to 1500, and then I click write changes. Well, what I can do is if I refresh this, or even if I don't refresh this, but in my case I'm refreshing it, I can click select data and you'll see find point CGI 1500 and 100. And that's because if we look at here, we have 1500 for our elo and our score is 100. So it's really that easy to interact with our database. So now you might be asking, okay, that's really cool, very simple. How do I update data? Well, that's actually really simple as well. So if we take a look at our Godot code here, our Godot project here, and we duplicate our select data, let's go ahead and change this to update data. And then let's come over to our inspector and type update data. Now I'm going to come in here. I'm going to duplicate these two, put them over here. Let's drop that in here. Let's change this from text edit 2 to score value. And then let's just say score. We'll change this to score like that. And now if we come in here, we go into our update data, we click on node, we right click, disconnect it, right click, connect it. We're going to control A, copy it. Let's connect it to our control node. We'll come down here and we'll say public void paste. We're going to bracket that guy. And then all we have to do to update our data is basically pull back our context, update it, and then we're done. I know you're thinking, hold on, there's no way it's that simple. And it really is that easy. So if we come in here, we can just say bar players is equal to, and let's just pull back our context players where to list, right? So we'll basically do this. So we're basically doing a selection statement. So we'll say context find point CGI to list. We'll say if our players dot count is greater than 0, which it should be just because we're, doing this hopefully the correct way. And then all we have to do is say where the name is equal to find point CGI. Instead of doing that, let's just say get node bracket. And I believe we have it right here. So we'll pull back that text edit. So we'll say text edit dot text to list. So that's going to let us get a little bit more flexibility. And then what I'll do is I'll say players bracket 0 dot score is equal to, and we'll pull back our get node, and I believe it was called score. So we'll change this to score dot text, and I'm going to wrap this because you can see it's mad at me. It says, hey, we can't convert string to int. So I'll say int dot parse, and we're going to parse that information like that. And now if we just refresh, you'll see here that if I come in here, I select my data, you'll see we have find point CGI 1500, 100. Let's go in here and say find point CGI, and let's change our score to something like 500. If we click update data, you'll notice that we have an error. Unable to cast object type rich text label as type text edit. That is because I was supposed to do score value like that. And something else that I forgot is that we need to save our context. So let's say context dot save changes like that. So now if we come back here, refresh our project, we'll type find point CGI. We'll click select data. You'll see that it's going to show our data as expected. We'll change our score to 500. We'll click update. We got no error, so that's good news. We click select data. You'll see that find point CGI has been updated with 500. And you'll notice that if I refresh the database, it has been set to 500. So that's all you need to do to basically update your data. So what is this doing? Well, what we're doing is we're pulling back our data from our context right here. And then we're coming in and we're updating our score to our score value, right? Just like a regular object. And then we're saying context.save changes. So we're telling our database or our entity framework to actually go in and save the data. And it's really that simple. And now you might be asking, okay, so that's great. How do I actually delete data? Well, thankfully, deleting data is just as easy as selecting and updating data. All you have to do is if you come in here, duplicate the button. Let's come down here. Let's right click disconnect, rename this to delete data like that. Right click connect. We'll connect it right here like so. Come down here and we'll say public void, paste it, bracket. And then to be able to delete an object, it's actually not as bad as you might imagine. So first things first, we have to select our data, much like we did up here. So let's go ahead and just grab this. Easy enough. And then in order to just be smart and code our stuff correctly, we'll make sure that we have a player of some description. So if we have that player, then all we have to do is type context dot remove parentheses, and then we have to pass in the entity we're trying to remove. So players bracket 0. And then much like before, we have to save our context. So context dot save. And then if we change the name, the text of this button to delete data like that, we hit play and we look, we have a name called test right here. So let's go in and type test. And then let's make sure that we refresh this database. So here's our data. We'll click delete data, hit refresh, and you'll see that we deleted one of our data sets right here. Now, what happens if we want to delete multiple ones? So let's insert a couple of them like that. So you'll see that we have a bunch of our test data sets right here. What happens if we want to actually delete a bunch of them? Well, that's really simple as well. I'll just come in here and say for each player in players, like that. Then we can basically just remove that from our context. And that should just work. There we go. There we go. And that should just work. Now we can refresh. We can come in here, type test, hit delete data, and you'll notice that we don't have any errors. So if we go back to DB browser, we hit refresh, you will notice that all of our stuff got deleted. Awesome. So now the question is, how do I actually run custom commands? A lot of times when people are doing SQL, they want to actually run specific commands just for a specific interaction. So sometimes you might want to insert 1,000,000 rows or something fancy like that. And that's where custom commands kind of come in. So if we head over to our project here, let's just go ahead and duplicate delete data and say run custom command. And then I'm going to come in here and hit custom command. Then we're going to go into node, right click, disconnect, right click, connect. I'm going to control A, control C, connect. I'm going to scroll all the way down to the bottom. Public void on custom command button down. And to run a custom command, it's actually really simple. All you have to do is say var rows is equal to context.database.execute SQL raw. Now what that's going to do is it's going to return back the data that you expect it to. So basically, anytime you affect a row, it will come back right here. When you execute, this little section here is basically going to be where your SQL is going to be located. So what we can do is say update players set score equal to, and actually I think we should do elo instead. So we'll go elo equal to, and we'll go bracket bracket 0 where, and let's pass in name is equal to bracket bracket 1, like that. And now you might be saying, okay, why do you have these brackets here, right? Why do you have 0 and 1? And the reason why is because that's how you pass in parameters. So if I hit comma, and let's say 5,000, like that, comma, and then I pass in something like find point CGI, what that's going to do is it's going to take these values and it's going to put them in to here. And that's basically how it works. And now all I have to do is come in here and say context.save changes. And technically speaking, you don't have to do context.save changes, but it's just a good idea and to be consistent. So if you don't want to do that, you don't necessarily have to. I just like to do that for my own case. Now, if you were to print out those rows, so gd.print rows, it should be an integer saying this is the number of rows that were affected. So if you come into Godot after saving this and you hit refresh, when I click run custom command, you'll see we get a 1, and you will see that if I go into our DB browser here and I refresh, you'll see our elo is now 5,000. So that's basically how you run custom commands. Typically, 99% of the time, you're not going to do this, right? But I like to show it so that way you guys have that flexibility. Executing custom SQL is very important. It's actually really useful. So now the question is, okay, so I have my model, right? I have my players here. What if I want to add something else? Let's say guns, right? So what do I have to do? Well, that's pretty simple. If you right click your model and type guns and add in a guns class here, we can type public class gun, like that. And I guess I should probably rename this to gun. It's not guns. A list of gun is guns, correct? So Then we just have to come in and add in our values. So public int ID, get semicolon, set semicolon. Let's go ahead and add in public int ammo, public string name, let's say. And let's assign a gun to a player. So we'll say public int player ID, like that. Now, typically, you wouldn't see this in normal code, right? You wouldn't see a player ID value, right? Well, the reason why is because in databases, you need to link stuff to other things. Now, you could have a table of just guns that don't link to anything, right? And you could have an adapter table, right, to kind of connect the two. But for the sake of the tutorial, I'm not going to do that because that's going to go way beyond the basics of how all this works. So we'll just go ahead and do that. Now, our players can own guns, right? So we'll say public list of type gun, guns. And I'm going to put in bracket get semicolon, set semicolon, just like that. And now if I come in here, I can add another DB set called gun, like that. And I'll rename it guns, just like that. Simple enough. So now we have a couple of options, right? We can go ahead and delete our database and then recreate it, and that will have our new stuff. So we'll do that real quick. So if we actually just change the name of our database, let's just go with database 2. So data 2, like that. That way I don't have to delete the database. So we'll just change the value of what our database is. So that way I don't have to delete it. I'll explain why in a minute. We'll need to update our schema, basically, is what I'm thinking. So once I do that, if I come into Godot here and I run our project here, it's going to go ahead and create a new database. So if I head back to our project here and then I refresh, you should see a data2.db. So now if I open up that database, you will see that there is now two tables. There's gun and players. You'll also notice that there is a player ID parameter, and you'll notice that it has a little tiny key icon like that. So what does that mean? And you'll also notice that our list of guns don't exist. So what in the world's going on? Well, Entity Framework understood what we wanted it to do. It understood that our player can have a gun associated with it. So what it did was it took the name of our model object here, our gun model object player ID, and it matched it with player and ID and said, oh, I understand what you're trying to do here. And then we also have this list of guns. So it understood just by that little bit of information that our gun needs to have a player ID and that it needs to actually hook to the other one as a foreign key constraint. If you right click and modify our table, you'll notice that it's a not null. That means that it's required. Now, there are ways around that, right? You can tell it not to be required, right? Things like that. But in this case, I will allow it to have that requirement. And if you want this to be nullable, all you have to do is come in here, go into here and say public int question mark player ID. And then if we close this database and then we go back to our SQLite, we delete this database and we rebuild it like so. If we reopen that database and we open up our guns table, you will notice that it no longer says that it's not nullable. That means that we can actually make this a null value and it doesn't matter, right? We don't have to have anything associated with it. That means that when you build out your model objects, you have to be real cautious and just make sure that you have a question mark where you say, I do not always expect information to be here. If you don't always expect information to be here, make sure you throw a question mark and it will basically just handle it for you. So now you might be asking, okay, so how do we step up our inserting, right, to handle this additional thing, right? So we have this foreign key right here to our player ID. So how do we actually handle that? Well, basically, it gets handled for us. We don't have to do any special work. If we come into our insert here and we come in here and we say current player dot guns is equal to a new gun, right? That, then we could say guns current player dot guns dot add, and we can add in a new gun bracket bracket. We'll say name is equal to Glock, and then we'll say ammo is equal to 12. Now you'll notice that I'm not populating our player ID, right? I'm just ignoring it. And I'm also ignoring our ID as well. If I come in here and I duplicate this like so, and then I say HK for an H&K gun, and I say the ammo is 8 because I think most HK pistols are 8. If you come in here like that and you hit Control S, when we go into our Godot project and we refresh, if we type test and we insert the data, you'll notice that nothing really has changed. But if we go into our database and we go into browse data, you'll notice that it inserted that data and it associated it with the player that we expected it to. So that's kind of the power of all of this. So if I come in here and I type find point CGI and I insert that data, you'll notice that when I refresh, we have find point CGI, and on the guns table, we have another copy of Glock and HK, and we have a player ID of 2. So it automatically created all those links for us. We didn't have to do any of that special stuff. So the beauty of this is that it works really well when you don't want to worry about your database architecture as much. You can just basically say, build the thing, and it builds the thing. So that's one of the nice things about it. And what's even cooler is you don't have to worry about database ordering, right? So in a lot of SQL code, you have to actually worry about ordering. But if you click delete data, and then I come in here and I browse my data, you'll notice that it removes my player. But if I go into my guns, you'll notice that our gun now has null information. So what gives, right? Well, basically, because we set our value as null right here, or nullable, then that means that it can be deleted and actually can exist without a player attached to it. So it doesn't automatically get cleaned up. So that's something else to keep in mind. So if I get rid of that and then I come in here, let me pull these guys away. So I'll delete them like that. I'm going to write those changes, go to database structure, right click on guns. We'll modify that table and make it not null again. This is basically just to stop us from needing to recreate the database. But if you guys want to do that, you guys can. So I'm basically just setting up the database so that this doesn't crash out. Because if something's required, but it isn't required in the database or vice versa, it can crash. So it can cause problems. But if this is set to not null and our database is set up correctly, when we refresh this, we can come in and say find point CGI. We can insert that data. Come in here, take a look at our database. You'll see we have our ID with our player right here. And then if we come in here and we delete that data, you'll notice that if I refresh this, find point CGI is gone and our actual gun is gone as well. We only have the one for our test object. So that's just something to keep in mind. But the beauty of this is that it all basically just gets handled for you instead of you need to go through the whole process. Now, at this point, you have a very basic understanding of how to use Entity Framework. Now, let's talk about some caveats. So, unfortunately, with the way that Godot does its SDK, you cannot use the Entity Framework command line to interact with your database. So that's one major limitation that you will need to be aware of. So if you can't do it through code, then you can't do it through this system. So what I mean by that is if you are going to migrate data from one database to another, for instance, let's say later, right, you say, hey, I want my gun to be able to have an ammo pool, right? You can't just say, okay, I'm going to add this parameter, right? You need to do a database migration for it to automatically detect the changes and then add it into the database. And unfortunately, there's no real easy way to do that currently. So you'll need to code around that. And the reason why is because if you do a entity framework database update, so if I type .NET EF space database update, you'll get an error here that just says, hey, this doesn't work, right? Unable to retrieve project metadata, ensure it's an SDK style project. And unfortunately, the way that Godot works is they don't make it an SDK style project, they make it their own custom project. So because of that, you can't actually run these commands, or at least I haven't found a way for us to run those commands. So that's something to keep in mind. So something to kind of mitigate that is to create a custom, if I go into game context here, to create a custom database updating script that just kind of runs and makes sure that everything's happy. And to do that, it's actually not as bad as you might imagine, but you just need to be real cautious with how you approach your stuff. Basically, you're just going to need to make sure that once you have your context created and you have your option builder put in, you basically need to come up with a way to more or less alter your table. So if I come in here and I take a look at this, if I come into my ready and I run a custom SQL. So if you remember, we have a custom SQL down here. This is part of the reason why I covered custom SQL. If I come up here and I drop this custom SQL into my ready, what I can do is I can alter my table. So I can say alter table player, add column, and then let's say I want to go into my player and I want to add a column called address, like that. If I go over to my entity framework, I can say alter player, add column, and I can say address, and I can make that into, I believe it's a type text. And I can hit quote. And that should add that into the database. Now you're going to need to check to verify that this has not already ran. So you'll need to make sure that you save that data somewhere. So my guess would be I would put it in my database and basically just keep track of what level my database is at. Let's say my database version is 6 and my most recent database version is 12. Then I know I need to execute 6 through 12 to get me up to that version. Now that's a little bit beyond what we're kind of doing right now, but that's something that is useful to know. It's a good way to approach it and it makes things relatively simple. But now if I just go into our Godot project and I hit play, as soon as this runs, in theory, it should just run and execute correct. And you'll notice that it failed here. It says unknown table, no such table as player. So that's my fault. If we take a look at our entity framework, alter table player, it is players. If I drag this guy over, players. And capitalization doesn't really matter, although it is standard to capitalize all this. So technically I should say alter table, add column, like that. Technically that's considered standards. Now, if I come into here, I refresh this, you'll see that if I refresh that database, we go to our players, you can see name, ID, ELO. If I refresh this table, you can see that our address has been added. So that's kind of how you can approach adding things inside of Godot, inside of the code. Now, normally this would just get handled by Entity Framework, but unfortunately, it can't be. Now, if you want it to get handled automatically and you don't want to think about it, but you don't care about the data that's in the database, then what you could do is you could come in here. Let's comment this guy out. And then we can come up to our game context. We can type database dot, and you'll see that there's a bunch of options here. Can connect, close connection, commit transaction, start transaction, and transactions are definitely beyond what we need. But what we can do is we can come up here and type database dot ensure deleted, like that. And what that'll do is that will delete our database, our data2 here, and it will automatically just rip it out, right? So we can come in here and say MO pool, and then we can type get set like that. And then we can come back here to Godot, refresh. And what it's going to do is it's going to kill that database, which I actually have open. So it's probably not going to like that. So I'll close it for right now, refresh it real quick. And then if I open up DB browser for SQLite, and then I drag in that database right here, you'll notice that our gun has the MO pool. But because of that, it now just deleted all of our data. So that's something else to keep in mind. Now, at this point, that's pretty much everything that I can teach you about Entity Core Framework up to this point. If I learn how to do migrations manually, I will definitely create a follow-on tutorial to explain it and to go through the process. But as of right now, this is pretty much everything that you need to know to get started understanding Entity Core Framework. So if you like this video, go ahead and hit that like button. Hey, you know, if you dislike this video, go ahead and hit that dislike button because I'm here to make content for you guys. This video was a viewer suggested video. So, hey, you know, if you have any suggestions, please leave them in the comments below or jump on my GitHub. Link is in the description and leave a ticket. If you create an issue, I will get to it eventually. And hey, if you have any questions or comments, please leave them in the comments below or jump on my Discord. Link is in the description and anyone there will be more than happy to help you out. But that is all I have for you guys today. So thank you so much again for watching, and I will see you all next time. Thanks.